Hello बच्चों, good morning. So I welcome you all again your favorite channel Physics Made Easy by DCP myself Dayalchand Pathak. So in class 10th we were discussing about the chapter magnetic effects of current. किसके बारे में पढ़े थे? Magnetic effect of current. Yes, do you know that when current flows through the wire, when we will connect any wire through a battery or a cell, then a current starts flowing through that wire. That current produce two effect. Number first, when current flows through the wire, that wire is heat up. That is called heating effect of current. Number second, according to our state, when current flows through any wire, then that wire is produce magnetic effect, magnetic property around itself. मैग्नेट जैसी प्रॉपर्टी अपने चारों ओर पैदा कर देता है. दैट इज कॉल्ड मैग्नेटिक इफेक्ट ऑफ करंट. लेट्स सी, इन लास्ट लेक्चर वी हैव डिस्कस्ड, सपोज दिस इज a straight wire. Through this wire current is flowing, suppose from bottom to top, down to up. Suppose the current is flowing from down to up. According to our state, this wire will produce magnetic field around itself. ये वायर अपने चारों ओर क्या पैदा करेगा? मैग्नेटिक फील्ड. So that magnetic field is depend on the current and distance from it. In last lecture we have discussed. To find the direction of that current, we use which rule? Right hand thumb rule. Right hand thumb rule. For that, what you have to do? You have to keep your right hand thumb in the direction of current. Means suppose the current is going from bottom to top. Then what you will do? You will put your finger in the direction of current. See. I have kept my finger. तो आपको अपने थंब को किसकी डायरेक्शन में रखना है? In the direction of current. Direction is current is coming going down to up. So I have kept my finger thumb in the direction of current. Then you curl your finger. See, this is the direction of current. Magnetic field. So the fingers will represent the direction of magnetic field. This is called right hand thumb rule. What you have to do? You have to keep your finger thumb in the direction of current. आपको अपना थंब किसकी डायरेक्शन में रखना होगा? In the direction of current. Then you will see and curl the fingers. Then you will see the fingers will point it in the direction of magnetic field. Clear? So fingers किसको represent करेंगे? Direction of magnetic field. So same chapter we are going to continue. Now today topic is what? Today we will discuss about magnetic field due to current carrying circular coil. What we will discuss today? We will discuss about magnetic field due to a current carrying circular coil. In last lecture, if you have not seen, first go through that lecture. In that we have discussed about a state wire. Now today what we have to do? Let's see. Suppose we take a cardboard. This is a cardboard. Now this wire, this is state wire. If we will curl this state wire in circular shape like this. Yes, if we will curl a state wire in the shape of circular loop like this, and we connect its two ends, these two ends. If you will connect these two ends through battery, a current start flowing through this wire. Yes, when the bottom these two ends, if you will connect through a battery, then a current start flowing through this wire. Is it clear? Now, according to our state, when current flows through the wire, it will produce a magnetic field around it. ये अपनी चारों ओर क्या पैदा कर देगा? Magnetic field. Now, what you have to do? This is the circuit. Now, when current flows through this wire, suppose the current is flowing from like this, left to right, like this. Then, according to our state, this wire will produce magnetic field. What you will do? You will take compass needle near it. आप इसके नजदीक क्या ले जाएंगे? Compass needle, and you will trace its path. So our task today to find out the direct magnetic field due to a circular. So what we are doing today? Today first of all, what we will do? We will take a wire and we will curl that wire in the shape of circle like this, like this. Now, when current start flowing through this wire, till it is not connected through battery, जब तक ये बैटरी से connected नहीं है, no current, no magnetic field. If we will connect it through battery, current start flowing through it, and it will produce its own magnetic field. Our task is to find out that magnetic field. Let's see. So what we will do? We'll take a cardboard like this. I have taken. This is cardboard. On that cardboard, what we'll do? We'll take a wire in that cardboard. So this is the wire. and this wire will be connected through battery, plus and battery or cell, plus and minus. When it will connected through battery, a current start flowing through it. Let the current through this wire is I. So according to our state theory, a current carrying object produce magnetic field. तो ये भी तो ये current carrying object है. It will produce its own magnetic field. Yes. Now the magnetic field produced by this wire, this circular coil. The magnetic field produced by this circular coil at its center. Magnetic field produced by circular coil at its center depend on following factors. The magnetic field which it will produce, जो magnetic field ये produce करेगा वो इसके सेंटर पे किन किन बातों पे डिपेंड करेगा. नंबर फर्स्ट, magnetic field directly depend on current. किस पर डिपेंड करता है डायरेक्टली? ऑन करंट. दैट मीन्स magnetic field is represented by B, so B directly depend on I. That means if you see a circular coil in which current is flowing through that circular coil, it will produce magnetic field. It will produce magnetic field. The magnetic field produced by this coil is depend on following factor. Number first, the magnetic field directly depend on at its center. We are going to find out at here at the center of the circular coil. The magnetic field at the center of the circular coil is depend on the following factor. Number first, it directly depend on the current. Meaning when the current will be more, then magnetic field will also more. अगर करंट ज्यादा होगी तो मैग्नेटिक फील्ड भी क्या होगी? ज्यादा. करंट डबल होगी तो मैग्नेटिक फील्ड भी क्या हो जाएगा? डबल. नंबर सेकंड, मैग्नेटिक फील्ड directly depend on number of turns. That means the magnetic field produced by this wire is directly depend on number of turns also. What is the number of turns? Per unit length. Number of turns per unit length. Per unit length means at 1 unit length how many numbers? Yeah, आप कह सकते हैं it directly depend on number of turns. Means how many turns are there? What is the meaning of turns? See here. This is how many turns are there? 1. Like this we can take many turns. हम बहुत ज्यादा 2 ले सकते हैं, 3 ले सकते हैं, 4 ले सकते हैं, 10 ले सकते हैं. So more turns, more magnetic field will be there. यहाँ पर कितने turns है? 1. तो it will depend that on the turns. If turn will be more, then obviously the magnetic field will be more. ज्यादा लोग होंगे तो ज्यादा magnetic field होगा. That means it is directly depend on number of turns. Number third, magnetic field inversely depend on radius और distance. किस पर डिपेंड करती है? रेडियस और डिस्टेंस पर इनवर्सली डिपेंड करते हैं. मींस B inversely depend on 1 upon R. See, current is flowing here. Current is here. Your task to find out the magnetic field at this point. Let this radius is R. So it is inversely depend on this R. Means when R will increase, like this, here we want to find out. So how many factors are there? Number first, current through this wire directly depend. Number of turns, more current, more magnetic field. Number second, it depend on the radius. Means from that point to this. If the distance will increase, obviously when the distance will increase, this loop will be move away. अगर डिस्टेंस बढ़ेगी तो लूप कहाँ जाएगा? बाहर, अवे जाएगा. सो अवे जाएगा तो उसका इफेक्ट भी क्या होता जाएगा? कम. दैट मीन्स मैग्नेटिक फील्ड वैल्यू विल डिक्रीज. सो दीज आर द 3 फैक्टर्स ऑन विच द मैग्नेटिक फील्ड ड्यू टू ए सर्कुलर कॉइल इज डिपेंड. नंबर फर्स्ट, डायरेक्टली डिपेंड ऑन I, directly depend on number of turns, and directly inversely depend on the radius of the circular loop. Is it clear? So that means when you will increase the current, so question, this type of question you will get. Board as पूछेगा, if the current through a circular loop is doubled and other factors remain same, what will be the effect on the magnetic field? The magnetic field of that circular loop will also doubled. If the number of turns are doubled, then magnetic field are also double. So that means these are the three factors on which it depend. Yes, this is very important thing. From here you will get the direct question. You have to keep these things in your mind. If these things will increase, if radius will increase, suppose for example you have two loop. This is the first loop. Current flowing through this loop is I, its radius is R, and there is another loop, same current flowing through this loop and its radius is 2R. And in which loop, question पूछा, in which loop the magnetic field will be more at center? किस लूप में मैग्नेटिक फील्ड ज्यादा होगा, इसमें या इसमें? सी I same, radius is just 1 turns is n is 1, I same, that means I same, n is same, what B inverse depend on R. So whose R is more? इसका R ज्यादा है तो इसका मैग्नेटिक फील्ड क्या होगा? Less. So magnetic field will be more in small loop. So this type of questions we will discuss about these all questions after that. Now, so how many factors is going to depend? It depends on 3 factors. Number next, we have to discuss that direction of magnetic field of circular coil. Now our task, find out what are the rules for the direction of magnetic field due to the circular coil. Now see, what our task? Our task to find out the direction. See, this is the circular loop. In this loop current is flowing. Maybe current here too, like this. Maybe the current flow like this. 2 cases are there. Maybe current flow like this or maybe like this. Yes. So what we will do? What are the rules? Now for finding the direction of this magnetic field depend on 3 factors. So what will be the direction? Direction of magnetic field will be checked by right hand thumb rule. So again we will check the magnetic field by which rule? Right hand thumb rule. Means same rule we have to apply. Here some differences are here. Fingers will represent current. Fingers किसको represent करेंगे? Current को. And thumb represent magnetic field line. That means here are some differences are there. Here the thumb, we will use same rule, right hand thumb rule. In that rule, here the fingers will represent what? Direction of current. Then thumb will represent direction of magnetic field. Let's see, we will apply. Suppose this is the coil. Now the current, let the current is flowing like this. Current कहाँ जा रही है? Left to right. What we will do? We will take our right hand and we will put our finger in the direction of current. Current is moving like this. So we will put our finger in the direction of current. So now where is the thumb? See? We will put our finger in the direction of current. Thumb is coming. See? In this, thumb is coming inward. Yes? Suppose the current is flowing like this. Agar current ऐसे आ रही, then again we will put our right hand in the direction of current. Thumb is coming outward. So that means here using right hand, when you use right hand, you will put your finger in the direction of current. The thumb will represent direction of magnetic field. Yes? So if current is flowing like this, we will put our right hand fingers in the direction of current. Clear? Let's see on the board how we will draw the magnetic field lines. Let's see. Suppose this is the circular loop. This is the circular loop. And in this circular loop, current is flowing like this. Suppose this is the current direction. Current is flowing in this direction in this circular loop. Now what you have to do? क्या करना है आपने? You will do one experiment, activity. In that activity, you will take a circular loop like this. The current flowing this circular loop is like this. Then you will take iron pieces on this board. क्या लेंगे? Iron pieces. Iron छोटे छोटे लोहे के पीसेस ले लेंगे, छोटे छोटे है ना, यहां पर. क्लियर? अब जब आयरन्स के पीस आप यहां पर डालेंगे, देन यू विल चेक दैट हाउ दे आर मूविंग. इफ यू विल चेक देम, व्हाट they will show that at center how, which type of lines you will get when they move like this. At center they move like this, at the corner they will show like this, and at the ends they will move in circular path. Why at the end they move in circular path? See, at the ends, if you will see at the ends of the circular coil, अगर आप circular coil के end को देखें तो this portion and this portion, it behave like straight line. ये किसकी तरह बिहेव करेगा? लाइक ए स्ट्रेट लाइन. एंड टू फाइंड आउट इट्स डायरेक्शन, व्हाट यू विल डू? यू विल पुट योर फिंगर इन द डायरेक्शन ऑफ करंट. सो हियर यू विल गेट द field lines circular. Here also you will get the field lines circular, and at the center straight line. That means here now see, this is the direction of current. Now what you will do? Current is flowing like this. Yes, you will put your finger in the direction of current. This like this, it is going like this now. So this is the direction of current. In 2D if you will see this, the current is going like this. जा रही ना? तो फिंगर रखेंगे like this. So in 2D if you will see how you will draw in 2D. 2D में कैसे ड्रॉ करेंगे? Let's see 2D में कैसे ड्रॉ करते हैं. This you can take, this is circular loop. This is the circular loop. Current is flowing in the circular loop. Now check how the current is flowing like this. See, current is flowing like this in circular. So what you will do? You will put your right hand fingers in the direction of current. Current is going like this. So this is, now check, thumb is coming down. That means the magnetic field lines will come from up to down, up to down, up to down, and at the ends they will be circular because the end will work like a straight wire. Ends किसकी तरह काम करते हैं? Like a straight wire. See this portion, it is like a straight wire. This portion is also a straight wire. After this it start curved, है ना? इसके बाद ही तो कर्व्ड हो रहा. Before that it is a straight line. So at the corner it will be like a circle. Now in the circle how will be the direction? It is going like this. This will be the arrow. Here also it will move like this. This is the arrow of direction of magnetic field. So you can easily draw the direction of magnetic field due to a circular current carrying loop at different conditions. Easily we can find out the direction of magnetic field. Yes. So this is very easy to find. How to find the direction of magnetic field? For that what you have to use? You have to use right hand thumb rule, or maybe you can use the directions of screw rule. Here is another rule to find the direction. Let that rule is screw rule. What that? Number second. If you are not able to find out by right hand, in that case what you will do? You will apply screw rule. What you will apply? You will apply screw rule. What is screw rule? आपने देखा ना टेस्ट पेचकस, स्क्रू घुमाना. ठीक है, देखिए क्या करेंगे. Let this is the direction. Maybe the direction like this, or maybe the direction like this. What you will do? You will check that in which direction current is flowing. Current is flowing like this. So you will take a screw and you will rotate your finger in the direction of that. कैसे जा रहा है? देखो कहां को जा रहा है? अंदर को. देखो स्क्रू को घुमाऊंगा in the direction of current. यहाँ को current is flowing like this. Same direction if I will remove this screw, move this screw. So screw will move inward. That means magnetic field lines will be inward. Here, see, the current is like this. If you will remove the screw, so it will come out. That means magnetic field lines are outward. How the magnetic field lines? Outward. So inward field lines are represented by cross, and outward is represented by dot. What is the meaning of cross? Cross meaning electric field lines are going from out to in, from outside to under the board. Screw is moved like this ना. Screw कहाँ जाएगा? अंदर. So cross. At the end box, जब आप ट्रेन को देखेंगे, ट्रेन के लास्ट डब्बे में क्या लिखा रहता है? क्रॉस. क्रॉस मीन्स होता है जाना. So it will move towards the paper, inward the paper, inward the board, and that dot means outward the board. So by this screw rule also you can find out that rule. So in screw rule you have to check. For example, suppose this is practically the current is flowing like this in this wire. Now you want to find out screw rule. See, current is flowing like this. So screw ऐसे घुमाना आपने. स्क्रू को अगर आप ऐसे घुमाओगे, करंट कैसे जा रही? करंट ऐसे जा रही. जिस डायरेक्शन में करंट जा रही है उसी डायरेक्शन में आपने स्क्रू घुमाना है. स्क्रू घुमाओगे, कहां जा रहा है स्क्रू? इनवर्ड. So magnetic field will be inward. मान लीजिए मैग्नेटिक फील्ड करंट ऐसे जा रहा है, सपोज करंट इज फ्लोइंग लाइक दिस, देन यू विल मूव द स्क्रू इन द सेम डायरेक्शन ऑफ करंट. Screw is coming out. Yes or no? So by screw rule also you can find out the magnetic field due to a circular coil. So there are two methods. By using right hand you can, and by screw rule. Any one rule you can use. Yes. So in screw rule you have to move in the screw in the direction of current. You have to move the screw in the direction of current. Suppose current is flowing like this. ऐसे मूव कर दिया तो आपको स्क्रू उसी डायरेक्शन में घुमाना है. एंड यू हैव टू चेक वेयर स्क्रू इज गोइंग. स्क्रू जहां जा रहा है दैट इज द डायरेक्शन ऑफ मैग्नेटिक. Get it or not? So it will be very easy. So which type of questions you will get? Let the question. Question number 1. Find direction of current in given diagram. Direction of current in given diagram. Your task to find out the direction of current in the given diagram. Suppose the diagram is this. This is. Now by any rule you can find out. On the board if you will see, on 3D you will see. So what rule you will apply, how you will show it. In 2D if you want to show the direction of current. See, in 3D if you want to show, so this is the direction of current. So you will take your screw and you will feed. You will move the screw. Screw is going inward. That means the direction of current is inward. Now you want to show the direction. So for that what you have to do, you have to take it practical applications like this. So what this is, and the current is flowing like this now. Yes, current is flowing in this way like this. So you will put your finger in the direction of current. This. Now see thumb. Thumb is going from up to top, down to bottom, bottom to up. So down to up, down to up, down to up. Then at the ends they will be circular, because at the end it will be circular. Now on circular, this wire will curl like this. So this is the arrow. This wire will curl like this. This is so these are the magnetic field lines due to this circular loop. So we can easily find out the direction of magnetic field lines on the circular loop. So this is called right hand rule or screw rule. By screw rule you can write that it is inward. If you want to draw, then for that you have to consider it in 2D. कैसे consider करना होगा in 2D. So this is very easy. So this was the. Now let the question is, next question we will take. That the question is not the question is find new magnetic field if current is doubled through a circular coil. When current is doubled through a circular coil. Other terms in that question there will be written, other things remain same. Other things remain same. So when this is the loop, like this is the loop of radius r, current through this loop we can take clockwise, anti-clockwise. This is the I. So now we know this question is from current. We know B directly depend on I. If I equal to 2I, अगर I डबल हो जाएगा, so this is B1, B2 equal to 2B1. अगर I डबल हो जाएगा तो करंट मैग्नेटिक फील्ड भी डबल हो जाएगा, बिकॉज मैग्नेटिक फील्ड डायरेक्टली डिपेंड ऑन करंट. इफ करंट इज डबल्ड देन मैग्नेटिक फील्ड इज आल्सो डबल्ड. Yes, so it is very easy to find out the magnetic field value and magnetic field directions by for a circular coil. So this is very easy. So which rule you have to keep in your mind? Screw rule or maybe a right hand. Which rule? Right hand thumb rule. Right hand thumb rule. Now next topic what we will discuss. The next topic what we will discuss about solenoid. Very important for 10th class. Solenoid. What? Solenoid. Now what is solenoid? See, solenoid, many devices are there. Solenoid, toroid, synchrotron, three devices mainly. When you will discuss in class 12th, you will discuss about three devices: solenoid, toroid, synchrotron. So these devices are used for the production of magnetic field. By these devices you can produce magnetic. So solenoid, what is solenoid? We can write that about the solenoid. We can write it is a device which use to produce magnetic field. It is used to produce magnetic field for different circuits, for different places. We can use this device to produce magnetic field. Number second question: how solenoid? How we will make the solenoid? How it will design? How solenoid work? What is the function? What is the diagram of solenoid? Now see how the solenoid work. See this. This is copper wire. What are these? This is copper wire. Now if I am going to take a copper wire, this is a copper wire. What we will do? If you will wound मतलब होता है मेना copper wire. Suppose this is a iron cylindrical piece. कैसा है? Iron का cylindrical piece है. We are taking a cylindrical piece of iron. This cylindrical piece should be of magnetic material. किसका होना चाहिए? मैग्नेटिक मटेरियल. मैग्नेटिक मटेरियल किसे कहते हैं? दोज मटेरियल्स विच आर अट्रैक्ट बाय मैग्नेट इज कॉल्ड मैग्नेटिक मटेरियल. इज कॉल्ड मैग्नेटिक. दोज मटेरियल्स which attract by magnet like iron, cobalt, nickel, and these materials are called what? Magnetic material. So what we will do? We will take a cylindrical piece of magnetic material. If you wound, if you wound copper wires in the shape of helix, this is called helix. Circle and moving forward, this is called helix. So what is solenoid? See, solenoid. If copper wires are wound, W-O-U-N-D, wound means मोड़ना. If you wound copper wire, अगर हम मेड़ेंगे copper wire को in the shape of insulated copper wire को in the shape of helix. What shape? Helix. This shape. Which shape is called helix? This is called circular shape. And if you will wound it like this circle and move forward, this is called helical shape. What is this? Helical shape. So if copper wires are wound on a cylindrical piece of magnetic material, if copper wires are wound in the shape of helix, किसके shape में? In the shape of helix, like this. Like this. This is called solenoid. When you will connect this is through a cell or battery, then a current start flowing through it and it will start producing magnetic field. This is called solenoid. So what is solenoid? We can write that if we will wound, suppose this is the cylindrical piece and these are the copper wire. If you wound copper wire in the shape of helix, that is called solenoid. That is called solenoid. उसे क्या कहते हैं हम? Solenoid. So this is a solenoid. Let's see. थोड़ा अच्छा सा बना लेते हैं बड़ा सा ताकि हम इस पे एक्सपेरिमेंट कर सकें. So helical shape. This shape is called helical shape. So what? If you will take a cylindrical piece of magnetic material like iron, cobalt. Normally you take iron piece. Then you will take copper wire and you wound that copper wire in the shape of helix. Circle like this. If you wound the copper wire in the shape of helix, this is called solenoid. So when copper wires are wound in the shape of helix over a magnetic material piece, cylindrical magnetic material piece, that is called solenoid. Now when you will connect this solenoid through battery or cell, मान लीजिए आपने इसे बैटरी से जोड़ दिया. Every battery have two terminal. Battery. Then what will happen? A current will start flow through it. Let the current through it I. Like this it will flow. Yes? Let the current flowing through it I. Then you know that when current flow through any wire, it produce magnetic field by or state theory. और स्टेट का कहना है कि व्हेन करंट फ्लो थ्रू एनी वायर इट विल प्रोड्यूस मैग्नेटिक फील्ड, सो दिस विल आल्सो प्रोड्यूस magnetic field. Now how, if it is going to produce magnetic field, so how many factors on which the magnetic field will depend? See, magnetic field produced by solenoid depend on following factors. Depend on the following factors. What are that factors? क्या होते हैं वो factors? Number first, magnetic field produced by solenoid directly depend on I. Obviously, the current is going to produce magnetic field. Current ही तो magnetic field produce कर रहा है. So it directly depend on current. Number second, the magnetic field produced by solenoid B directly depend on number of turns, means how many turns are there, कितने turns हैं इसमें, जैसे 1 turn 2 3 4 5 6, how many more turns. अगर आपने ज्यादा राउंड कर रखा है, ज्यादा वायर ज्यादा टर्न्स पे राउंड कर रखा है, बड़ा वायर को राउंड कर रखा है, मैग्नेटिक फील्ड विल बी मोर. लेस नंबर ऑफ टर्न्स होंगे तो मैग्नेटिक फील्ड भी क्या होगा, लेस होगा. दीज आर द टू फैक्टर्स ऑन विच मैग्नेटिक फील्ड ड्यू टू ए सोलेनॉइड इज depend. So when you will increase the current, magnetic field will increase, and when you will increase the number of turns, अगर ये turns को आप बढ़ा देंगे, mood, जैसे for example this is a solenoid and this is another solenoid, in which number of turns are more, here the number of turns are more, so that means the magnetic field produced by this solenoid will be higher than this one. If the number of turns will be more, magnetic field produced by that device will be, that solenoid will be more. So these are the two factors on which the magnetic field due to a solenoid is depend. Now next, now if this solenoid produce magnetic field, now we are telling that this solenoid is going to produce magnetic field, that means it will be magnet. इसका मतलब ये मैग्नेट की तरह बिहेव करेगा. So every magnet have two poles. Every magnet have two poles. Now how we will check that which pole of this solenoid is north and which one will be of south? क्या करेंगे देखिए ध्यान से. How we will check? Checking of north and south pole. Checking of north and south pole of solenoid. Checking of north and south pole of solenoid. Okay? Solenoid is going to produce magnetic field, its own magnetic field. So what we will do, we will check that which end of the solenoid will behave like a south pole and which end will work like a north pole. What you will do for that? You will see from this side. If you will see the solenoid this side, the turns are like this. Suppose the current is flowing like this. So what you will do? You will check if the current flowing थ्रू द कॉइल, जहां से आप देख रहे हैं, अगर करंट कैसे है, क्लॉकवाइज है, दिस इज कॉल्ड क्लॉकवाइज. क्लॉकवाइज मींस इन द डायरेक्शन ऑफ क्लॉकवाइज. व्हाट इज द मीनिंग ऑफ क्लॉकवाइज? क्लॉक ऑलवेज मूव लाइक दिस ना, घड़ी ऐसी घूमती है. इफ द करंट इज गोइंग इन द लाइक मूविंग अ क्लॉक, जैसे घड़ी घूमती है, अगर करंट वैसी घूम रही है तो दिस इज द राइट वे. आप याद रख सकते हैं, क्लॉक ऐसी घूमती है ना, तो अगर करंट ऐसी जा रही है तो आप कहेंगे सही है. सही है मींस विच पोल? साउथ पोल. सो इट विल वर्क लाइक ए साउथ पोल. इट विल वर्क लाइक ए साउथ पोल. नंबर सेकेंड, if the current flowing through the coil is anti-clock, means anti-clockwise. Anti-clockwise means just opposite direction to the clock. Clock revolve like this, current is going like this. तो आप क्या कहेंगे? No, this is wrong. No means here you make N, so it will behave like a north pole. It will behave like a north pole. So easily you can check. So here see, when you will see from this side, अगर जब आप इस साइड से देखेंगे, the current is going like this. जा रही ना ऐसे, ये, yes or no? Current is going like this. That means this pole is सही, साउथ। Here if I will see from this pole, अगर यहां से देखेंगे तो करंट कैसे जा रही है, ऐसे जा रही है। So this will work like नॉर्थ पोल, दिस विल वर्क लाइक नॉर्थ पोल। देखिए इसमें अगर आप देखेंगे सर्किट को, अगर गौर से देखेंगे तो इसमें कैसे चलती है, यहां से और यहां से आपने क्या देखना है, क्लॉक और एंटी क्लॉक, मींस करंट को देखना। अगर आपने घड़ी यहां से देखूंगा तो कैसे आ रही है, ऐसे ऐसे, सो ऐसे आ रही है, दैट मीन इट इज द राइट डायरेक्शन। राइट मींस सही है, सही है, सही है मींस दिस पोल इज एस, साउथ पोल, एंड द नेक्स्ट वन विल बी ऑब्वियसली नॉर्थ पोल। एवरी मैग्नेट है हाउ मेनी पोल्स, 2 पोल्स। अगर एक पोल आपने छाड़ लिया तो दूसरा अपने आप आपको क्या मिल जाएगा, जस्ट अपोजिट ऑफ दैट। सो दिस इज द नॉर्थ साउथ पोल एंड दिस इज द नॉर्थ पोल। दिस इज कॉल्ड सोलेनॉइड। सो दिस डिवाइस इज यूज्ड टू प्रोड्यूस मैग्नेटिक फील्ड। फॉर एग्जांपल लेट, आपसे पूछा दिस इज अ सोलेनॉइड, क्वेश्चन पूछा, सपोज दिस इज अ सोलेनॉइड and current flowing through this solenoid is this is the direction of current. Now your task, find out which end will be north and which end will be south. आपने बताना है कौन सा एंड नॉर्थ होगा, कौन सा। What you will do, you will check from this side, इससे देखे तो कैसे आ रही है, ऐसे ऐसे आ रही, तो कौन सा, राइट, बिकॉज दिस इज द डायरेक्शन ऑफ मोशन ऑफ क्लॉक। घड़ी ऐसी चलती है, सो करंट भी ऐसी जा रही है, दैट मीन्स हियर विल बी S, south pole, south pole. So this one will be north pole. ये क्या होगा, अगर ये साउथ है तो उसके अपोजिट वाला क्या होगा, नॉर्थ पोल। इट इज जस्ट अपोजिट, है ना, क्लियर। सो यू हैव टू चेक दैट इन विच पाथ, इन विच वे। सो एक क्लॉक है या एंटी क्लॉक है, आपको चेक करना होगा। इस डायरेक्शन में देखेंगे और इस डायरेक्शन में देखेंगे कैसे जा रही है। तो साइड से देखते हैं, दोनों साइड से, क्लियर, चेक। सो दिस इज कॉल्ड सोलेनॉइड। नाउ व्हाट आर द यूज ऑफ सोलेनॉइड? सोलेनॉइड, आई हैव टोल्ड यू, सोलेनॉइड इज ए डिवाइस व्हिच इज यूज्ड टू प्रोड्यूस मैग्नेटिक फील्ड। बट what there is a quality of the solenoid. If you will see, suppose you are going to take a solenoid, suppose this is a solenoid, मान लीजिए एक सोलेनॉइड है, एंड द सोलेनॉइड करंट इज फ्लोइंग लाइक दिस, करंट फ्लोइंग थ्रू द सोलेनॉइड इज लाइक दिस, क्लियर, लाइक दिस। नाउ इफ यू विल टेक ए आयरन पीस इनसाइड दिस सोलेनॉइड, अगर आप इस सोलेनॉइड के अंदर क्या ले लेंगे, एक आयरन पीस, लोहे का पीस, दिस इज आयरन पीस। इफ यू विल टेक a iron piece inside a solenoid, then what will happen, this iron is magnetic material. What is this? Magnetic material. Magnetic material, those materials which are attracted by magnet are called magnetic materials. So iron is a magnetic material. So when you will take a magnetic piece of magnetic material, कोई भी iron, cobalt, nickel, if you will take a piece of magnetic material, if you take a piece of magnetic material inside a solenoid, this will also magnetize, means this piece will behave like a magnet. ये piece भी क्या बन जाएगा, एक मैग्नेट, और इस तरह से बना हुआ। अब ये जो मैग्नेट बन गया, ये piece क्या बन गया, ये piece बन जाएगा मैग्नेट, एंड दिस मैग्नेट इज कॉल्ड इलेक्ट्रो मैग्नेट। क्या बोलते हैं इस तरह के मैग्नेट को, इलेक्ट्रोमैग्नेट बोलते हैं। क्या बोलते हैं, इलेक्ट्रोमैग्नेट। व्हाट इज इलेक्ट्रोमैग्नेट? इफ वी विल टेक ए पीस, सी फर्स्ट वी विल सी 2 केसेस आर देयर, लेट 2 केस कर लेते हैं, आराम से आपको समझ आ जाएगा। देखिए सपोज दिस इज ए सोलेनॉइड, copper wire in the shape of helix is called solenoid. This solenoid is connected through battery and current flowing through the solenoid is like this. Yes. Now, if you will take a iron piece inside this solenoid, magnetic material like iron, if you will take an iron piece inside it, iron, then this iron will be magnetized. ये आयरन क्या हो जाता है, मैग्नेट। ये क्वालिटी होती है सोलेनॉइड की। इफ यू विल टेक आयरन पीस इनसाइड द सोलेनॉइड, मान लीजिए सोलेनॉइड की कॉइल है, इनसाइड द सोलेनॉइड कॉइल इफ यू विल टेक आयरन पीस, आप इसके अंदर क्या रख देंगे, एक आयरन पीस रख देंगे। सो दिस आयरन पीस विल बी मैग्नेटाइज्ड। क्या हो जाएगा, मैग्नेटाइज। इट विल बी मैग्नेटाइज, इट विल प्रोड्यूस इट्स मैग, दिस it will be magnetized, called इलेक्ट्रोमैग्नेट। अब ये मैग्नेटाइज हो जाएगा, मीन्स ये भी मैग्नेटिक बिहेवियर शो करने लगेगा, ये भी क्या बन जाएगा, मैग्नेट जैसा बिहेव शो करेगा। और इस तरह से बने हुए मैग्नेट को क्या बोलते हैं, इलेक्ट्रोमैग्नेट। क्या बोलते हैं, इलेक्ट्रोमैग्नेट। इट इज वेरी स्ट्रॉन्ग मैग्नेट, ये बहुत ज्यादा स्ट्रॉन्ग होता है। ये तभी तक मैग्नेटिक बिहेवियर शो करेगा जब तक क्या फ्लो होती रहेगी, करंट। इफ यू विल स्टॉप द करंट इट विल डिमैग्नेटाइज। जब आप करंट को रोक देंगे तो अपने आप ही क्या हो जाएगा, डिमैग्नेटाइज्ड हो जाएगा, नो मैग्नेटिक इफेक्ट। So what is electromagnet? When you will take iron piece inside a solenoid, solenoid, magnetic field of solenoid magnetize that iron piece, and this type of magnet is called, अब वो मैग्नेट बन गया, उस मैग्नेट को क्या बोलते हैं, इलेक्ट्रोमैग्नेट। बट इट विल बी shows the magnetic property जब तक इस पर क्या फ्लो होती रहेगी, करंट फ्लो होती रहेगी थ्रू दिस coil. Till that it will behave like a magnet. If you will stop the current, it will stop its magnetic, it will lose its magnetic property. So this magnet is called what, electromagnet. But if you will take a solenoid, suppose this is a solenoid, and through this solenoid the current is flowing like this. This is the direction of current, right? Now if you will take a steel piece, which piece, steel, अब आपने इसके अंदर किसका पीस रखा है, स्टील पीस, देन दिस इज ऑल्सो मैग्नेटाइज्ड। दिस स्टील पीस विल ऑल्सो मैग्नेटाइज बिकॉज स्टील इज ऑल्सो यूज्ड टू मेक ए आर्टिफिशियल मैग्नेट, सो दिस इज ऑल्सो मैग्नेटिक मटीरियल। सो इफ यू टेक ए पीस ऑफ स्टील और स्टील अलॉय, ऐसे अलॉय जिसमें स्टील यूज हुआ हो, तो ये क्या हो जाएगा, ये भी क्या हो जाएगा, मैग्नेटाइज हो जाएंगे, एंड इट विल प्रोड्यूस आल्सो मैग्नेटिक फील्ड एंड दीज आर आल्सो मैग्नेट। क्या बन जाएंगे, मैग्नेट बन जाएंगे। कैसे मैग्नेट बन जाएंगे, आर्टिफिशियल। बट दिस स्टील इज कॉल्ड परमानेंट मैग्नेट। व्हाट इज दिस, permanent magnet. Why it is permanent magnet? Because steel have a quality, it's a retentivity. I will not go to explain you about retentivity. When you will come in 12th, you will come to know about it. Steel retentivity is very high. Due to that reason, when it magnetize, after that if you will stop this current through the solenoid, अगर आप solenoid से current को stop भी कर देंगे, still there will be magnetic property in the steel. तब भी स्टील पे क्या रहेगी, मैग्नेटिक प्रॉपर्टी। तो स्टील विल रिप्रेजेंट इट्स, ड्यू टू दैट रीजन इट फॉर्म ऑलवेज परमानेंट मैग्नेट, एंड दिस इज इलेक्ट्रोमैग्नेट। वेयर दिस इलेक्ट्रोमैग्नेट इज यूज्ड, दिस इलेक्ट्रोमैग्नेट इज यूज्ड टू फाइंड आउट द आयरन फ्रॉम सम प्लेसेस। आप मान लो किसी जगह से आपको आयरन को निकालना है, तो आप इस इलेक्ट्रोमैग्नेट का यूज कर सकते हैं। It will lose its magnetic property when you will stop this current, and it will not, this permanent magnet will not lose its property if you will stop the current flowing through it. Now let suppose the question is there, you have to draw, मान लो क्वेश्चन है, draw magnetic field line for solenoid। मान लीजिए आपके पास क्वेश्चन है, ड्रॉ मैग्नेटिक फील्ड लाइंस फॉर सोलेनॉइड। नाउ लेट दिस इज ए सोलेनॉइड, दिस इज ए सोलेनॉइड एंड दिस सोलेनॉइड इज कनेक्टेड थ्रू बैटरी और सेल, प्लस दिस इज माइनस। नाउ व्हेन करंट विल स्टार्ट फ्लोइंग थ्रू दिस सोलेनॉइड, दिस like this the current will flow. Now you will see from this space, आप इस space से देखेंगे, current is flowing like this। कैसे हो रही है, ऐसे जा रही है। So that means S, south pole is this. Number second, now if you have taken this, the current is flowing like this, so you will put your fingers in the direction of current, the thumb are coming like this, so the fingers are thumb is coming left to right, you will put your fingers, let's see, थोड़ा इसके ऊपर बना लेते हैं, तब आपको ज्यादा समझ आ जाएगा. लेट दिस इज आयरन पीस, iron cylindrical piece, magnetic material cylindrical piece, and on this we are going to wound copper wires. Let these are the copper wires on it. These are the copper wire on it, and we will connect that copper wire through battery, and let the current start flowing through this wire is I, like this. Okay, now you have to draw the magnetic field lines due to this solenoid. So what you will do, you will put your fingers in the direction. For magnetic field lines we have to use right hand palm rule or right hand thumb rule. You have to use right hand thumb rule. For that what you will do, you will put your fingers in the direction of current. This current is going like this, the curves are coming like this, curves as are. So like this you will put anchor. These are the current. So thumb is coming from left to right. That means magnetic field lines from left to right. At the corner left to right. At the corner it will be left to right. And at the ends they will be circular path. They will be in circular path. So now see this line, when this line will curve, so the arrow will be like this. When this line will curve, the arrow will be like this. So these are the magnetic field lines due to a solenoid. Now inside the solenoid, if you will see inside the solenoid, the magnetic field lines are parallel to each other. सोलोनॉइड के अंदर जो मैग्नेटिक फील्ड लाइंस हैं वो एक दूसरे के क्या होती हैं, पैरेलल. दैट मींस फील्ड इज यूनिफॉर्म इनसाइड सोलेनॉइड. सोलेनॉइड के अंदर जो फील्ड होता है वो क्या होता है, यूनिफॉर्म होता है, एक जैसा होता है. मींस इट्स वैल्यू विल रिमेन सेम एट एवरी पॉइंट. ड्यू टू दैट रीजन द लाइंस इनसाइड द सोलेनॉइड्स आर यूनिफॉर्म, पैरेलल टू ईच अदर. बट एट द कॉर्नर दे आर नॉट पैरेलल. सी हियर दे आर नॉट पैरेलल because here the magnetic field is different than inside. Corners पे magnetic field अंदर से हाफ होता है. मींस magnetic field at corner equal to magnetic field inside by 2. मैग्नेटिक फील्ड जो कॉर्नर पर होता है वो इनसाइड से कितना होता है, हाफ होता है. ड्यू टू दैट रीजन इट विल बी नॉट यूनिफॉर्म वायर एट द एंड्स, यूनिफॉर्म एट द एंड, बट inside the solenoid it will be uniform because the magnetic field is same at every point. So I hope that you have learned something from this today lecture. So I request you, if you love it, if you like it, and please share it, subscribe the channel and share it with your friends. More members should be in our this family. So फिर मिलूंगा एक नई वीडियो एक नए थॉट के साथ. सेम चैप्टर को कंटिन्यू करेंगे. तब तक के लिए बाय.